So in this video, we're going to do density. And in density, we are going to go over some calculations and what it means. So solid, liquids, and gases are characterized by two things, mass and a volume. You can measure the mass using a mass balance or scales with an S, or you can do the volume using a measuring cylinder and a eureka can, and we'll go through that later. You can simply compare the materials by looking at the mass and the volume separately, like I've said just there. You can measure that mass, measure that volume. But typically, solids have a large mass and a very small volume because all the particles are close together. So you think of highly dense means the particles are close together, and low density means the particles are far apart. Okay? Gases typically have a small mass contained with a large volume. So large volume, but hardly any particles floating around. If you imagine each particle weighs a certain amount, okay, then if you've got more particles in a small space, it's going to weigh more. It's going to have more mass. It makes sense. Now, density. To compare densities, we use the density with this symbol rho. I'm not going to worry too much about rho. Okay, and you need the mass and the volume. So mass divided by volume, density equals mass divided by volume. Or you can rearrange it and have mass equals density times volume, or we have got volume equals mass over density. And you can rearrange all of those so you can get each different thing. Now, it's more than likely in your course that you're just going to use this one, mass divided by volume. Now, the unit of density is kilograms per meter cubed or grams per centimeter cubed. Now, if it's physics, it's the kilogram per meters cubed. If it's chemistry, it's grams per centimeter cubed, just because of the size of the things you're measuring. So in physics, you're measuring kilograms of stuff. In chemistry, it's usually grams. Now, you get that by doing this. So if you want to do chemistry, it's grams per centimetre cubed, okay, which it gives you this unit, grams per centimetre cubed, or kilograms per metres cubed. Kilogram divided by metres cubed is this kilograms per metres cubed unit for density in physics. Now, density of water, very simple calculation we're going to do, is 1,000 kilograms per metre cubed, or 1 gram per centimetre cubed. So what that means, basically 1 gram of water equals 1 centimetre, because it's 1 gram per 1 centimetre. So 1 gram per 1 centimetre. So basically that means 1 gram of water is 1 centimetre cubed. You can calculate the density using that, because you know that 1 gram is 1 centimetre cubed, so you've got a mass and a volume. So the mass is there, divided by the volume equals the density of water, which is 1 gram per centimetre cubed. Okay. Now let's have a look at some different densities here, and you can see some different densities here. So if we look at the yellow one, if you look down, it says solid, liquid, and gas. That's a gas. Obviously, air is a gas. And then you've got petrol and water, which are both liquid, and then the rest are solid. You can see that as the density goes up, it's more likely to be a solid. That's because the particles get closer together, they weigh more, they've got more attractive forces between them. So basically, they become a solid. Now, not always the case though. If you look here, expanded polystyrene is a solid, but it's got a very low density. That's because it traps lots of air in it and things like that. But it's really a general trend is that the more dense it is, the more likely it's going to be a solid. Now, said before, we need the volume, we need the mass. So masses of several grams can be measured using a balance, okay? And that's what we'll normally do in a lab. Okay, if you do kilograms, you usually have scales. Okay, now the volume of liquids can be measured using measuring cylinders. Okay, so we can get the volume. Remember, it's mass divided by volume. So we can get the volume using a measuring cylinder, and we'll talk about that in a bit. Volumes of regular solids can be done with maths. So basically, if it's a cube, you can just do the length times the width times the height. Okay, and then irregular ones we can do by displacement in a measuring cylinder, okay, and large objects can be used using a displacement can, also called a eureka can. We'll talk about that in a bit. So, very important thing about density is related to buoyancy. So if something floats, okay, it's got to be less dense than the liquid it's in. So if you look at water here and you've got the iceberg, okay, that means that the iceberg is less dense than the water because it floats. So as you can see up here, an object will float if the density is less than surrounding liquid or gas. So this liquid is water, this is ice, this must be less dense than the water. And the same thing with the balloon. It's less dense, the air in the balloon, than the air around it, so it floats. Okay, and the opposite, it will sink if its density is more. than the liquid or gas. So if you drop a piece of metal into water, generally that metal will sink because it's more dense than the water itself. And the density usually goes from solids, liquids to gases. So more dense in the solid, less dense in the liquid, and even less dense in the gas. So very simple. Measuring the volume, we're just going to go through a couple of measuring volume slides. If you measure the volume, you have to do it using maths if it's a simple shape like a cuboid. So just basically the length times the width times the height. And just use the unit that's there. And you can use that, remember it's mass divided by volume. So you can then use that in the V part once you've calculated it. Now, if it's an irregular solid and it's awkward, can't be calculated, you can lower it into a partially filled measuring cylinder. And then the rise in the level of the liquid gives the volume of the object. And sometimes it's necessary to push it down if it floats. So let's have a look at this. And you can see here, here's my original level. And then there's the rock. And then you can see the difference between here and here is going to be the volume of your rock. Okay, and that's the best way of doing it, really. It's a really, really good way of doing it. We're now going to do the Eureka can, and the Eureka can is a way of measuring the volume of irregular solids, just like the measuring cylinder. But what we do is have a can of this shape with a spout, and then you fill it up to the edge of the spout with water. You then place the irregular solid in. We've got a crystal. We placed it in. That makes the volume go upwards. Okay, so the volume increases, and it'll increase by the amount of volume of the irregular solid. And then the excess goes over the edge, down the spout, and into a measuring cylinder. That volume of liquid that's in there is the volume of that irregular object. Okay, so the 4 points you need are, it can be lowered into the Eureka can. The rise in the level of the liquid causes the liquid to come out the spout. The excess water is collected in a measuring cylinder, and the volume of the water is the volume of the object. Remember to fill this up to the edge of the spout if you're going to do it. Okay, so these are your points that you need to use a Eureka can. Our next example is called a Cartesian diver. So a Cartesian diver demonstrates buoyancy and pressure. So what you have is you have a little diver, which is this thing here. Okay, and it's placed in a bottle, and the bottle is filled with water. And you can do this at home, you can do this in a lab. It's really, really easy. We just used a pipette here. Okay, now squeeze the bottle, it makes it sink. You can make the diver sink or float. So let's move on. This one, if I squeeze, it forces the water into this pipette. Forces it in, because the water doesn't compress. Like water doesn't compress, it's a liquid, it doesn't compress. But the air inside here compresses because it's a gas. So it compresses. So the water then goes up and in. That means this is just as dense or more dense than it was before. Okay, and it's just the same density as the water. So what it does is it sinks. Okay, it starts to and it sinks. Now, when you let go, the water comes out of this, and then the air expands, which means the air is then less dense than the water around it, and so it floats. So with this one, you squeeze to force the water in to squash the air, so the air increases its density, and this one, you let go, and the air expands out again, and the air is less dense and so floats. But the explanation of this is quite simple. Less air in the diver, which means it's more dense, which means it sinks. More air in the diver, less dense, which means it floats. Okay. Now, in this video, what we talked about is measuring the volumes and measuring the masses. Remember, with density, it's mass divided by volume. You can measure your volumes using a Eureka can. You can measure them using a measuring cylinder. Okay, and you can measure your mass using a balance. And all you have to do is divide the two terms, and there you have your density. I hope this is of use. Please like, subscribe, share. Most important thing, share, so it can help as many people as possible. Thank you.